All right. So firstly, understanding what exactly is even and odd functions. So the objective is going to be understanding even and odd functions. So we'll develop the understanding about even and odd functions. There are certain things that we need to firstly understand. Uh, what do you mean by even function? Now, as a key concept, even functions are basically where you see f of negative x. Suppose if you've been given y equals to f of x as some function. Now, if f of negative x is same as f of x, we call the given function is even function. Given function is even function. Now, what does this mean in lame terms? Basically, if you replace x with minus x of in a given function, and if you get exact same expression as earlier, okay. So if you get exact same function, now for example, if my function is, let's say, x squared plus 4. Now here if I replace x with minus x, so if I find out f of minus x, it will be negative x the whole square plus 4, which is x squared plus 4 itself. Now you can see that it's exactly same function. So it is an even function, even function. Now, also, what does it mean in terms of point mapping is, let's say if you got a point 1 comma 3, even if I take negative 1 comma, it'll be the y value 3, because whether you change x to negative and vice versa, if it is negative you change to positive, your y value should not change. So that's the meaning of even function. Now, even functions, if you see, common sense is that if you're, like for example, 1 comma 3 is, let's say here, the negative 1 comma 3 is here, you can see that it's symmetric about y-axis. So I can just take the same graph, y equals to x squared plus 4, that is also symmetric about y-axis. So every even function, even functions are symmetric about let's say y-axis. So even functions are symmetric about y-axis. Now, what is odd function? Now, if you talk about odd functions, if you got f of minus x, and if it is exactly negative of the original function, if f of minus x is negative f of x, it is odd function. Now, a simple odd function I can give an example of is, let's say, x cube function. Now here, if you replace x with negative x, you'll notice that will be negative x the whole cube, which is negative x cubed. So if the function becomes exactly negative of the original function, then we call it as an odd function after replacing x with negative x. So in terms of point mapping, if you see 1 comma 3, now it becomes, if I take negative x as negative 1, it becomes negative 3. So in short, what happens is if I got 1 comma 3, it will be negative 1 comma 3. So generally we talk as this is going to be symmetric about the origin. So any odd function, like for example, x cube function that we did, is going to be symmetric about origin. Even functions generally have only one rotational symmetry, and odd functions have two rotational order of symmetry about origin. If I rotate this around origin, you can see that you get the ideal function. If you rotate by 180 and then here you'll rotate by further 180, you get again another same function. So when you talk about the even and odd function, these are the basic representations. Now let us take some certain problems that can help us. So let's take the example where you have got f of x is 2x plus 3 and x plus a. They have given that find a such that f is an even function. So now in such case, obviously, what we do is, since it is an even function, it's pretty simple to write down the relation first, since f of negative x is f of x. So replace x with negative x will become, or you could just open the bracket first, it makes a lot of sense. So it'll become 2x squared plus 2ax plus 3x plus 3a. So if f of negative x I'm writing, f of negative x is basically 2 times negative x the whole square plus 2a times negative x plus 3 times negative x plus 3a, and this should be equals to the original function, which is this itself. So it is 2x squared plus 2ax plus 3x plus 3a. So if you open up the bracket, I mean, if you simplify the left side, you get 2x squared minus 2ax minus 3x plus 3a, and it is equals to 2x squared plus 2ax plus 3x plus 3a. So 2x squared cancels, 3a cancels, and we are left with 2ax here and 3x here. So if you bring it here to the left side, or you bring it to the right side, you get 2ax plus 2ax plus 3x plus 3x equal to 0. So basically now if I take x common, you get 4a plus 6 times x equals to 0. Since x is non-zero number, 4a plus 6 is 0. So 4a plus 6 is 0 you get. So you get a as negative 3 over 2. So this is a very simple problem solving based on what you have got, like, what you have understood. Now, let us talk about the next part, which is the function when it is function is odd. So f of x is basically, they have given us that it is x plus 1 and 1 over x plus b. So once again, you simplify this, open up the brackets, it will become 1 plus bx plus 1 over x plus b. So this is the simplification of this bracket. Now, since f of negative x, it is going to be 1 minus bx minus 1 by x plus b, if it is equals to negative of f of x. So it is same as negative of 1 plus bx plus 1 by x plus b. So you get negative 1, negative bx, negative 1 over x, negative b, equals to 1 minus bx, negative 1 over x plus b. Bx and bx cancel, x cancel. We get eventually 2b plus 1 equals to 2b plus 2 equals to 0, because this 1 comes this side. So this gives us b as negative 1. So these are some of the logical, ways to do the problems, like, based on the even and odd function. So we have been given that f of x is even function. So firstly, it means that if you have f of negative x, it is going to be going to be the same as f of x, and g of negative x is going to be negative g of x. Now determine whether the function f of gx is even, odd, or neither. So f of g of x will be basically, if I replace x with minus x, so it'll be f of minus of g of x, because we know that g of x is an odd function. Now f of minus will become same as f of g of x itself. So this is an even function because it is same as f of g of minus x. All right, so in this question, we have got ln f of x is ln x plus root 1 plus x square is an even function or odd function. We have to just check out on that. Okay, so obviously, as we know that, firstly to check f of a function whether it's even or odd, so f of minus x we find out, so it'll be ln of negative x plus root 1 plus x square. Now, since we see, actually, like here, I have replaced x with minus x, but since square of that is positive, so I'm not writing that. So since we can see clearly, it is like, we don't have any step further to go beyond this. But if we rationalize this function, like, so I take root 1 plus x squared plus x and root 1 plus x squared and plus x. Now this will become ln of 1 plus x squared root the whole square minus x squared upon root of 1 plus x squared plus x. Now this root disappears, x squared and x squared get cancelled, and you get ln of 1 upon this. So ln of 1 upon can be written as negative ln x plus root 1 plus x squared, which clearly you can see here that this is the negative of the original function. So if f of negative x is negative of the original function, it means this is f of negative x basically is negative f of x. Hence, it is an odd function. And this here I apply the property of ln 1 upon x or log 1 upon x is negative ln x. So that's how I got this step. So this is one of the very interesting question that like has been assessed in one of the exams. Similar question, not the exact one.